Let's take a look at terminal numbers and reference numbers. For the setup here, I have a unit circle. So again, that's a circle centered at the origin with radius 1. And within each quadrant, there are three line segments going from the center of the circle out to the actual surface of the circle itself. And those each have a length of 1 unit because they're the radius of the circle. Okay. In the first quadrant, we can see that those three radiuses correspond with a pi/6 angle, a pi/4 angle, and a pi/3 angle. Okay, and those three lines are symmetric in all four of the quadrants. Okay, so if we are given the terminal number 2 pi/3, how could we locate the terminal point on the circle that corresponds to 2 pi/3? And then how could we identify the reference number that goes with that terminal number? Okay, so I guess we could start with this example to remember that 2 pi, if you remember, 2 pi is the rotation for a full circle. So it's a full revolution around the circle is 2 pi radians. And since this is the unit circle, which has a radius of 1, if we apply the arc length formula, not only is it 2 pi rotation, 2 pi radians of a rotation, but the circumference of the circle is also 2 pi. So the distance to travel around the circle is 2 pi. Okay, so that means if we have the terminal number 2 pi/3, we need to divide the entire circle, which is a distance of 2 pi, divide it into thirds, divide it by 3. Okay, and it would be nice if we could put one of those divisions along the x-axis. So let's try that. So we're going to take our circle, we're going to draw sort of a radius along the x-axis. That's our first division. And then we're going to draw two more to divide this circle into thirds. Okay, so if we look here, we've taken the entire circle and divided it into thirds. Okay, so each of these sections, the length of each of these parts of the circle has a length of 2 pi/3. So that's 2 pi/3 from the x-axis into the second quadrant, and then from the second quadrant down into the third quadrant is also a length of 2 pi/3. And then from the second quadrant, if we travel all the way, or sorry, third quadrant, if we travel all the way back to the origin, or to the x-axis, sorry, then we've also traveled a distance of 2 pi/3. Okay, so each of those three arcs of the whole circle have a length of 2 pi/3. So if we think about starting here at the x-axis, and we sort of travel in a counterclockwise distance, then that means starting at the x-axis, when we get through that first 2/3, that first third of the circle, we have traveled a distance of 2 pi/3. And if we continue traveling, then once we get to the next division, we will have actually traveled twice that. So we've traveled 4 pi/3. And once we get back to our start, so that's a full loop, we have then traveled 6 pi/3. Well, if you simplify 6 pi/3, that just turns out to 2 pi, which should make sense. We've divided the circle into 3 equal pieces, and then we've just traveled over all 3 of them. So that's the distance of 2 pi. Okay. So we can kind of already say we know that the point that corresponds to t equals 2 pi/3 has to be in the second quadrant, and it's where that first third of the circle, where that division occurred. And so we could find where the 4 pi/3 is down here in the third quadrant, and so we could kind of find any of these points, right? But let's dig into this a little bit. If from the x-axis to that first division, to where we divided it into a third, that is a distance of 2 pi/3. That means that right in the middle of that is just half of that. So that's a 1 pi/3. Okay, and that means the same thing that is going to happen somewhere between 2 pi/3 and 4 pi/3. And so if we divide it right in the middle, well, what's between 2 pi/3 and 4 pi/3? Well, that would be 3 pi over 3. Well, what's 3 pi over 3 equal to? Pi, right? And so that has to be at the x-axis. And if we do this one more time, if we go from 4 pi over 3 to 6 pi over 3, there has to be a 5 pi over 3 here in the middle. Okay, so what we kind of see here is that there is a way to divide the entire circle. We could have divided 2 pi over 3 and just divided it into thirds, but we can break those in half to get even smaller divisions of 1/3. Okay, and so now if I look at these 1/3 divisions, well, 1/3 of pi, well, pi is half of our circle. It's, maybe the top half of our circle. So pi over 3 means that we're dividing the top half of the circle into 3 equal parts. So we have 1/3 or pi over 3, 2 pi over 3, and 3 pi over 3. Those are the 3 equal distances in the top half of the circle. And we get the same thing that happens in the bottom half of the circle. So we go from 3 pi over 3 to 4 pi over 3 to 5 pi over 3 and then 6 pi over 3. Okay, so if we think of it, so we're not always going to be given a 2 pi over a number. We're usually just going to have pi over a number or some other number that's not a 2 in front of the pi. And so we need to break this division process down into the smallest values that we can. And in this case, that smallest division would be using a pi over 3. Okay, so but we still get to the same point. If we use a pi over 3 division and we travel 1 pi over 3, and then we travel another pi over 3, right? So we've traveled pi over 3 twice, we still end up at 2 pi over 3. Okay, so we get the same place regardless of how we do it. Okay, so either way, we know that the terminal point for the terminal number, 2 pi over 3, has to be in the second quadrant. Okay, and if we also want to find the reference number, well, the reference number is the shortest distance from our terminal point to the x-axis. So it could go clockwise or counterclockwise to either the positive or the negative x-axis, but it's always got to go the shortest distance. So here in the second quadrant at 2 pi over 3, we could travel either clockwise to get down to the negative axis, or we could go clockwise to get to the positive x-axis, but it's much shorter to go to the negative x-axis. Okay, and since this distance from 2 pi over 3 to pi, which is where the x-axis is, it is just one distance of pi over 3. And so I know that that has to be my reference number. So usually for reference numbers, we might use t bar as our notation. So we could say our reference number, t bar, would equal pi over 3. All right, so let's try this again, but using something where the denominator is not 3. So our next example, let's look at t equals 3 pi over 4. Okay, so again, we're dealing with a 3 pi, so it's not a 2 pi, so we can't equate this to the entire circle. So instead of looking at the entire circle, let's just think in terms of pi. Okay, so I know if 0 is the positive x-axis, pi has to be the negative x-axis. And if I write pi with a common denominator, it would look like 4 pi over 4. And so that means I want to break the top half of the circle into a quarter, into quarters. Okay, and that way, because it will be pi over 4. So we have the x-axis, we have the negative x-axis, we have the y-axis. So that's divided the top of the top half of the circle in half. So that's pi over 2. We want to go further though and divide it into fourths. Okay, so each of these little arcs here represent a distance of pi over 4. So, and notice that each of these divisions, each of these distances end up precisely in the middle of each quadrant of the unit circle. Okay, so of the 3 lines that we have, the pi over 4 lines are going to be in the middle, and we just saw a minute ago that the pi over 3 lines were actually at the top. Okay, which is going to show us here in a minute that the pi over 6 lines are closest to the x-axis. So pi over 6 is closest to the x-axis, pi over 3 is closest to the y-axis, and then pi over 4 is in the middle. Okay, but let's finish up this problem here. We're trying to do 3 pi over 4. So we're going to travel 1 pi over 4. And then we're going to do 2 pi over 4. Well, it turns out that 2 pi over 4 actually simplifies down to pi over 2. So it's at our y-axis there. And then we need to go one more section. So one more group, or one more arc length of pi over 4. And so 3 pi over 4 is going to end up here in the middle of the second quadrant. And we could actually keep going like this. We could, we got to 4 pi over 4 at the x-axis. We could say 5 pi over 4 was down here in the third quadrant, and then 6 pi over 4 would be down here. Excuse me, would be down here on the negative y-axis, and then 7 pi over 4 would be down in the fourth quadrant, and then if we kept going, we'd hit 8 pi over 4, which 8 pi over 4 is 2 pi, so it's back to the x-axis, right? So we could keep counting, so we don't have to stop at 8, right? We could say 9. 9 would correspond to where pi over 4 is, and then 10, 11, and 12, and so forth. Right? So we can keep counting all the way around. Anyway, though, t equals 3 pi over 4 represents a point in the second quadrant. And if we want to find its reference angle, again, it is the shortest distance from that point to the x-axis, which is the distance of one of these pi over 4 arcs. And so the reference number here is going to be pi over 4. So we have t bar is equal to pi over 4. Okay. Hopefully you're kind of getting the hang of this. We'll do one more with a different denominator, and then we'll look at a few more examples. Okay. So next, let's look at t equals 5 pi over 6. Okay. So this time, just like we saw in the last example, we need to divide not the whole circle, but just pi. We need to divide the top half. So we need to divide the top half into 6 pieces because 6 is the denominator. So we use the x-axis as our two ends, so the positive x-axis and the negative x-axis. I could divide that in half, and then I divide each half into thirds. All right, so notice now here the pi over 6 measurements. So each arc here is a pi over 6 length. Notice that these include pi over 6, pi over 3, and pi over 2. Okay, so there's a lot that we get with pi over 6. Okay, and that's because pi over 6 is, that's because pi over 3 is really 2 pi over 6. So if we used a common denominator, and pi over 2 is really 3 pi over 6, right? And you notice we're counting already. So we have 1 pi over 6, 2 pi over 6, 3 pi over 6. So if we kept going, 4 pi over 6, 5 pi over 6, and then 6 pi over 6, which again, 6 pi over 6 is really just pi, okay? And we could keep going. We could divide the denominator into 6 and keep counting around, right? That's just counting numbers around. It's pretty easy. So we wanted 5 pi over 6, which lo and behold, here's another point in the second quadrant. And then we want to find our reference number, which is the distance from that point, again, to the negative x-axis. It's not always going to be the negative x-axis. It just is here because I apparently used all 3 points to be in the second quadrant. So this distance is the same distance as all of these other divisions. So it is also pi over 6. And so my t bar, my reference number, is again pi over 6. So if you just look at the 3 examples we've done so far, 2 pi over 3 had a reference number of pi over 3, 3 pi over 4 had a reference number of pi over 4, and 5 pi over 6 also had a reference number of pi over 6. And so these pi over 3s, pi over 4s, and pi over 6 values, those are the ones that are in the first quadrant. So what we're basically doing is trying to equate any of the points that we have outside of the first quadrant. So in the second, third, and fourth quadrant, we're trying to equate them back to a point in the first. Okay. All right, so let's do a few more examples and then we'll be done. All right, so our next value is t equals 7 pi over 4. Okay, so we want to divide up our circle, top half, we divide into fourths, bottom half, we divide into fourths. So we use 1, 2, 3, 4, 5, and then 6, 7, 8. Okay, so this would be 1 pi over 4. Pi over 2 is the same thing as 2 pi over 4, 3 pi over 4, and we saw this earlier, 4 pi over 4, 5 pi over 4, 6 pi over 4, so 7 pi over 4 is now a point down here in the fourth quadrant, and it's right in the middle of the fourth quadrant. If we try to look at the reference number, again, it's still the same distance as we have between all the other points, but this time it's going to the positive x-axis. So we have a point in the fourth quadrant, and my reference number is still just a pi over 4. Okay. All right, for the next one, we're going to look at a negative value. Does that change anything if we have a negative reference or a negative terminal number? Okay. All right, so for t equals a negative 4 pi over 3. If you remember when we had angles, and a positive angle meant we rotated counterclockwise. A negative angle means that we travel clockwise. So we're going to apply the same direction. So negative 4 pi over 3 means we're going to move in the negative direction. So we're going to move in the clockwise direction, and we're going to take steps that are pi over 3, and we're going to do 4 of those. So again, we're going to start here at the x-axis, positive x-axis, which is 0. And then we're going to have a negative 1 pi over 3. And that is at the line in the fourth quadrant that is closest to the negative y-axis. And then the next one in the third quadrant that's closest to the y-axis would be a negative 2 pi over 3. The x-axis would be a negative 3 pi over 3, because that's really just a negative pi. So that's half the rotation. And then a negative 4 pi over 3 would be up again here in the second quadrant, but we've traveled in a clockwise direction. Okay. That's in the pi over 4 location. So it would actually be up here. So that's a negative 4 pi over 3. And the distance from a negative 4 pi over 3, we're in the second quadrant, so we're going to go back to the negative x-axis. That is also, our reference number is again going to be pi over 3. Okay. All right, next, let's look at a negative 11 pi over 6. So again, this time we're going to divide the circle in our pi over 6s. So we're going to divide the top half by 6 and the bottom half by 6. So ultimately, we're dividing the whole circle by 12. So I'm going to go ahead and just kind of divvy these all up real quick. So you get a little, if you want to do tick marks like I'm doing, every line except for the pi's over 4, except for the middle one, is going to get one. So negative 11 pi. So negative means we're going clockwise in our direction. So this would be a negative 1 pi over 6, negative 2 pi over 6, which is the same thing as a negative pi over 3, a negative 3 pi over 6, which is the same thing as a negative pi over 2, and we keep going. So negative 4 pi over 6, negative 5 pi over 6, negative 6, it's negative 7, negative 8, and negative 9. So negative 9 pi over 6 would be at the y-axis. It's the same thing as negative 3 pi over 2, or positive pi over 2. And then we keep going, so we would get a negative 10 pi over 6, and then we would get a negative 11 pi over 6. So that negative 11 pi over 6 is actually coterminal with a positive pi over 6. So our terminal point is here in the first quadrant, which means our reference number is the distance there. So our reference number is again pi over 6. All right, one more. We want to look at 11 pi over 3. So we're going to divide the top half of our circle by 3. And if you're drawing the little tick marks, if you're looking at my graph here, I'm going to draw a tick mark at the lines that are closest to the y-axis, as well as the both sides of the x-axis. So that divides it into thirds right there. Okay. And so we just need to count around again. So 1 pi over 3, 2 pi over 3, 3 pi over 3, which again is pi. And we could speed this up again if I kept going. So 3, 4, 5, 6. 6 pi over 3 is the same thing as 2 pi. If I kept going, the next halfway around the circle would be 6, 7, 8, 9. So 9 pi over 3 is really 3 pi. And we have to keep going, right? We need 11. So that's 9, 10. So 11 pi over 3 is down here again in the fourth quadrant. And it really means that we have traveled counterclockwise around the circle almost 2 full revolutions. We are 1 pi over 3 arc length or 1 pi over 3 rotation from the x-axis. Okay, so we've almost gone 2 full revolutions. And again, here my reference number would again be pi over 3.